Very good morning, boys. So today let me see about types of boiling, pool boiling and flow boiling. So let me see the first classification of boiling. So pool boiling and flow boiling. It is called pool boiling in the absence of bulk fluid flow. So the water or fluid which is flowing very less amount, which is not bulk, that is said to be pool boiling. Flow boiling, second case, is called flow boiling in the presence of bulk fluid flow, in the fluid flowing bulkily, more amount of fluid. In case of pool boiling, any motion of fluid is due to natural convection currents and the motion of the bubbles under the influence of buoyancy. The buoyancy force is nothing but the force which is against the gravity, which is taking the fluid to the atmosphere when it is boiled. It happens in the pool boiling. Whereas in the flow boiling, the fluid is forced to move in a heated pipe or over a surface by external means such as pump. Already we discussed in the class what is pipe, what is tube. The tube is defined by inner diameter, pipe is defined by external diameter. The diagram explains about heating for both cases. In this pool boiling case, we can see the water is heated in a pan. So bubbles are formed at the bottom because of transfer of heat from metal to fluid, convection. So which is traveling upward because of buoyancy. Whereas in case of pipe, the heated fluid which is touching the wall surfaces first, because from the wall surfaces only heat is transferring, either the way, which is having the possibility of transferring heat through wall only. That is why the bubbles are nearby the walls, and which is moving because of flow pattern which is moving. So coming to the pool boiling, in case of boiling regime examination, this examination was done by the previous expert members and it is given with delta T to the Q boiling. We can see there are 4 processes involving it. One is natural convection boiling, second is nucleate boiling, third is transient boiling, fourth is film boiling. Here we can see the first delta T value which is less than 5. For the less than 5, so natural convection taking place. We can see here in this diagram. So here this is a natural convection taking place, the first phase. The second phase, which is classified into 2 types. One is bubble rise to the free surface, another is normal heating. After 100 degree, the bubble rise to the free surface. You can see bubble rise to the surface. It is due to what? Yes, buoyancy force. The third one is transition boiling. In case of transition boiling, the heat flux which is more, delta T falling above 30 to 120. So at the 100 degree centigrade delta T, we can see some vapor packets which is created at the wall surface where we are giving heat. After a certain period, which is moving into the delta T of 120 to 1000, where we can see the film boiling. In case of film boiling, you can see in the diagram. The whole surface have got the vapor packets. So which is giving more amount of heat to the fluid which is above that. So this is the boiling regime we have seen in the class. So based on the boiling procedure of delta T with the Q, this diagram was drawn by the previous expert member, which is very useful to solve any numerical problems for further analysis. Thank you very much.